Today is about designing for injection molding and in particular draft angle. Welcome to another episode. Well, as you may have noticed, it's been a little while since I made a video. There are a couple of reasons for that. The main reason is that my computer died and I'm still on crutches. Replacing a computer while you're on crutches and you have a broken leg is not the easiest thing in the world. It took me a little while. Couldn't have done it without my wife, of course. But I did get a new computer. It's much faster, and it took a while to install all the software that I needed, including the recording software, video editing software, etc. Plus, I worked on a few other projects while I was waiting for it, things that I could do with the computer once I installed some software. Anyway, this week, what I want to do is talk about the approach that I take when I'm designing a new injection molded part. And the important thing about injection molded parts is you need to have draft angle so you can pull it out of the mold. Again, molds are made like this and then they separate. And when they separate, you need to be able to pull the part out of the mold. Now, the other thing that happens is once you fill the mold with plastic, the plastic shrinks. Now, whether or not that's a good thing or a bad thing kind of depends on the geometry of the mold as well as the geometry of the plastic. So imagine that you have a piece of metal like this and you have a cylinder and it shrinks like this. That means it's going to be holding on really tightly to that cylinder, so it could be really hard to get the part off that cylinder. If, on the other hand, you have the walls at an angle like this, then it's a lot easier to pull it off that truncated cone. And one of the reasons for that is suction, air suction. Turns out once you mold it like that, there's no air down in here, so you have to break that suction to get the part off the mold. The shrinkage is another thing. But having a slight angle means that you move it just a tiny bit and you've broken that suction as well as the connection. So it's a really important thing. A lot of designers design their part without thinking about the draft angle and then try to add the draft afterwards. And that can be quite difficult to do sometimes. So I like to add the draft while I'm creating the part, and that's what I'm going to show you today. So let's head to the computer and get started. Here's a part that I designed quite a few years ago in SolidWorks. This is a cup that's designed to go on the front of a model railroad. You drill you cut a hole this diameter here, and then it goes in. And then you have a knob which you can use to pull in and pull out. And this goes through a push-pull tube which I have partially modeled here. And that tube is held in place with this clamp. There's a screw that goes here as well as a screw that goes here. This is not completely modeled because the screw goes through a hole on the other side and pulls it together. What I want to do today is take this model here and re-implement it in Fusion 360 instead of SolidWorks. And the reason I want to do that is because I'm in the process of switching over to Fusion 360. I want to make some changes to this design. And at the moment I don't have access to my SolidWorks license because I had to buy a new computer, and that means I have to deactivate the existing license and then activate it again. The other thing is my version of SolidWorks is fairly old now. It's 2011. And I don't want to pay the $5,000 it would cost to upgrade to the latest version. So let's take a look at how I approach this. This is going to be designed for injection molding. So one of the important things, as I've mentioned before, is draft angle. This has quite a bit of draft angle, and you can see it has draft angle right there. Now this part, as I've built it, also has the same draft on here. So basically it's designed so that this is the parting line for the mold, and then everything goes in here. Now I want to change that. One of the things that I do when I start building a part with injection molding in mind is I build the draft angles in from the beginning. So let me go ahead and create a new part. And, oops, not what I wanted. New design. And first thing I'm going to do is I'm going to save it. So I'll call this the fascia cup. And I want it in, let's see, in this folder here. I'm not sure why it's in that location. There we go. Okay, so going back to the other design, let's start with taking some measurements. The first thing is the outer diameter here. So I'll click on that, and you can see the radius is 28.44 millimeter. Chances are I did this in inches, so I'm going to switch to inches for this and see what it says in inches. Okay, 1.12 inches is the radius. So that means it's slightly less than 2¼ inches. So this looks like it's 2.24. And so the idea was it's a 1/4 inch hole. So let's go ahead and back to the other design. We'll create a circle. And it doesn't really matter which. I'm going to use this one here. Okay, so I'll put the circle right in the center. And then again, I'm going to switch to inches because we are in the US. I am in the US, and a lot of model railroaders use inches here in the US. Okay, now I'm going to set the dimension. I press the D key to 2.24 inches. Okay, so that's the diameter. And I'll go back to this. Let's see how deep we want that to be. So I'll go from, let's see, I'm going to go from the top here to the bottom. And you can see it's 0.9 inches. So that's the depth there. So we'll extrude. I'll move it this way, minus 0.9 inches. Now, I just made this a regular cylinder, and I actually want to make a change. Well, actually, I want to make a couple changes. First, let me go back. And I forgot to do something, which is it should always start with a component. So I'll say new component, and then this is going to be the cup. And then I'll add the sketch. So I'll do a circle. Switch this back to inches again. Dimension this to 2.24. Okay, and now let me extrude this. And I'm going to change this. So minus 0.9. I mentioned I want to add draft in from the beginning. So I'll make this draft 5 degrees. Now it's going the wrong way, so I'll make it minus 5. And I'm not sure if this is what we want, but yeah, it looks pretty good. And 5 degrees will make it really, really easy to get out of the mold. We could even make it last like 3 degrees and should still be fine to get out of the mold because this part is going to shrink, and so it's going to move away from the mold in this direction. So that'll actually work pretty well. Okay, now I want to add a radius onto it, which is right here. And it doesn't tell me what the radius is. So let's do it this way. Let me add a new sketch this way. And I'll just draw a circle here, or an arc. So I'll start there, end there, and then snap to there. And then I'll add a dimension to this. And what that tells me is that it's about 0.3 inches for the fillet. Okay, so we can go back to the other one. And I'll add a fillet. Where's the fillet? Wrong place. Modify fillet. And we'll make that about 0.3 inches. Okay, so that's looking pretty good. Let's take a look at this again. We also have a fillet here, but I'm going to add that later. The next thing we want to do is we want to cut out the middle here, which we can do with the shell command. So what I want to do is I want to find out how thick this is. Let's see if this works. I don't know if this is going to work. So I selected the inside, now selected the outside, and the two faces, the distance it says is 60 thousandths of an inch. That actually sounds about right. So I'll go back to the other one, and I'll use the shell command right here. I'll click this. The inside is 0.06, and now we have that shelled out, which is exactly what we want. Okay, so that's looking pretty good. Let's head back to here. Now I want to add this part out here. And let's measure this distance here. So that's 2.45 inches. So I'll go back and I'll add a square. So I'll do rectangle. Okay. Now one of the things I want to do is I want to make sure that this is centered. So I'm going to show you a cool trick. I'm going to create a line from one side to the other. And then I'm going to make that a construction line. And we could have done this just by sketching a center rectangle. But if you hadn't done that, I want to show you a cool trick. So the next thing we want to do is we want to select this here, select this line, and then we can say midpoint. And now it's snapped into position, and you can see that this moves the same on both sides. And it's a square, which is exactly what I wanted. Forgot the dimension, so I'll go back here, measure this again. 2.45 inches. Okay, so I'll dimension this. 2.45 inches. Okay, now let's take a look to see how thick I made that. So we can just click on this line, and it's also 60 thousandths. So I'll go back here, and I'll extrude. And this is going to be a little bit interesting. Now that I realize this, I'm going to change the order of things. And the reason I'm going to change, you'll see why. So let me actually extrude this down. Okay, and one of the things you'll notice is that I didn't actually create this plane. Yes, I did. Okay, so I'll extrude again. I'll extrude down. That's saying cut. We actually want to join. But it's solid, as you can see there, which is not what I wanted. I want a hole in there. And the reason I'm not getting the hole in here is because for some reason it's selecting this whole rectangle. In the past I've had it select lines like this. But that's easy enough to fix, because what I can do is I can move this before the shell command. So I'm going to take this sketch, move it before the shell, and then I'm going to extrude this. We can extrude it down, and so I'll make it minus 60 thousandths. Oops. And what I forgot to do is to make it join. Okay, so now you can see that I have it all joined the way I want. Now let's see what happens with the shell command. That's exactly what I wanted. So you can see sometimes changing the order of these commands, or whatever these are, these operations, can make it a lot easier to model something. Now outside of fillet here, let's go back and see how much that fillet is, if that'll tell us. No, it doesn't tell us. But we can go back to the sketch here and find out from that. So let's edit the sketch. I'll have to make this part transparent, which is, where is that? I always forget where that is. So what I'm going to do is I'm going to change the display setting. Here we go. I'll use wireframe. Okay, and now we can see that line there. So I'm going to draw another arc from there to about there. That's pretty close. That's not exact, but at least we can pick up a dimension and figure out, okay, so that's about 45 thousandths. Maybe a little bit more, but that's close enough. So I'll go in here and I'll add a fillet. Make it 0.045, and that looks nice. And the main purpose of this fillet is just to make it look nicer. Now the other thing I'm going to do is, which I forgot to do, is I'm going to go back to this operation here. And sometimes, by the way, you have to click here. You're just anywhere outside, and then you can get to the edit feature. And I forgot to add the taper angle. So let's make it a 5 degrees. And you can see that this time it's bowing out, moving outward like this. So it's thicker near here. Now that's good, because what I'll do is I'll make the parting line basically right here. And so this part here will go into the top part of the mold, and then this part will go into the bottom part of the mold. And that should work nicely. If I change my mind as to which is the parting line, you can easily go back and change this taper. Okay, I also want to have, that's interesting. Okay, it didn't change the visibility, but it changed it on its own. So let's take a look at the, it's interesting. It doesn't show me the fillet radius. Nope, radius 0.044, sorry, 0.44. So let's go ahead and add that radius. So we'll say fillet. We'll click here, 0.44, control click here, control click there, and control click there. And you can see we're getting pretty close, so I should save. That's a good idea, save often. Now, I also need these screw holes. So let me see what the distance is between these, the horizontal distance. 1.745. This is not really critical. These are just the screw holes used to hold this to the wood front of the layout. What I'll probably do is I'll probably actually have these screws be along a center line from there to there. So let me go ahead and do that, which is a different approach to things. So I'll add a new sketch onto here. And then what I'm going to do is draw a line. And what I'm going to do is I'm going to start by drawing a line from here to here. And I'm going to want that line to be at 45 degrees. So, and a construction line. Both of these will be construction. So I'll make this 45 degrees. Oops. Okay, looks like I need another construction line here. So make this 45 degrees. And then I'll add another construction line from here out to there. And what I'm going to do is select these two lines and then make them collinear, which is right here. Okay, so now that means I can draw a circle, centerboard circle, right here in the middle of that line. So that's going to constrain that circle, and then we can pattern that around. Let's see what the diameter should be. So 0.064, and I don't have draft on this, but I should. We'll fix that. So let me make this 0.064. That looks awfully small. Ah, that was the radius, 0.064. Times 2. All right, that looks much better. So that's a little bit more than 1/8 of an inch. And that sounds about right. So what I'm going to do is extrude that. And I'll go down and then say to object so that it's to the bottom, and that means if I change the thickness I don't have to worry about updating this. And then let me add that, I'll do 5 degrees because it makes it obvious. So if we look here, you can see that this is going the wrong way. Ah, that's odd. I must have hit the wrong thing. Okay, so we're not getting a preview here. So I'll just go ahead and do this. I usually don't like to do it that way, but Fusion seems to want me to do that. And what you can see is with this angle here, if the parting line here is and we have a little bit of the mold metal coming down here, it can be released. And we want this to be, 5 degrees makes it a little bit easier to pull this out, but 3 degrees should be fine as well. So I'll put that to 3 degrees and then click OK. And I haven't been labeling things, which I should, so I'm going to rename this to screw hole, or mounting screw hole. That way when we look back at the history, we know what this is. And then what we want to do is create a pattern, and I never quite remember where pattern is. So I'm just going to do search pattern, circular pattern. And what we want to pattern is a feature. The feature we want to pattern is this one here, and the axis is going to be this one here. We want to have 4, and there we have our pattern screws. So we're actually almost done here. The one thing we have left to do is to add this boss here and that hole. Now that hole has to be, let's check to this diameter here. So it should be a radius of 0.072. So let me go ahead and add that. Okay, and so the dimension on this is 0.072 times 2. Stop sketch, and then we'll extrude that. Let's see if I can do 5 degrees again. And so the idea is, whenever you're exiting like this, outside of one side of the mold with a hole, you want it to become wider like this, because this is going to shrink, and so the idea is you want to be able to move it just a tiny bit and have it lose contact with the piece that's coming down here, and that'll make it a lot easier to pull out. Again, I'm going to make this 3 because that should be fine. And then I'm going to try to do this to object again and see if it does it. Okay, now it did. So there we have the hole out the back. Now I need this boss here. Now this boss is interesting. Let me hide this piece here. It's interesting because, and let me go to a wireframe view. Okay. That's odd. Try that again. Okay, for some reason it stopped showing it. Now one of the things you'll see here is that I have draft on this part, but I don't have draft on this part. And it's a good idea to have a draft on both parts, because if you don't have draft on both parts, this is going to be really hard to get out of the mold. And it's going to be fairly deep down in the mold with the parting line here. So I'd have to have some ejector pins here to help push it out, but that's interesting. I don't know why. Okay, so if I rotate it, sometimes it loses the lines. Anyway, so let's take a look at the numbers here. Let me switch back to solid. Okay, and actually I want solid with visible edges. There we go. So what I have here is this starts out at about radius of 0.135. So let's go ahead and add that. We'll figure out the distance in a second. So I'll add a circle to here. And dimension I said was 0.135 times 2. We want to make these two things horizontal, so I'll select them and say horizontal vertical constraint. They don't really need to, but I'm just choosing to make them horizontal. I mean, the reality is this can be anywhere around here. The only important thing is the diameter of it and the distance from here to here. So let's find out that distance. Okay, so the distance from here to here is 0.206. So let's set that dimension. Dimension. For some reason, there we go. Okay, I did not get that right. Obviously, I don't understand what this means. So let me go back. Yep, I put in 0.206. So let me measure this with a sketch. Okay, dimension, click on the line. Okay, so it's 0.35. Okay, that looks much better. So let's extrude this boss. Let's see how high this is. I'm probably going to change that height, but we can at least look to see how high this is as a starting point. So click here, click there, and it's 0.45 inches. 0.45, and then give it an angle of 4. Okay, -4. Let me do a -3. Yeah, it looks better. Okay, then the final thing is this hole here, which is 57 thousandths radius. So we'll add a circle here. Dimension it. 0.057 times 2. Stop sketch. I had this going all the way down, but it turns out it doesn't need to, because there's a screw that goes in. What I'll need to do at some point is, is to measure that screw to see how far I need to go down. But for now, I'll just go down 1/4 of an inch. That sounds about right. And I'll give it 3 degrees, -3 degrees draft. And that should work out okay. Okay, so fairly quickly you can see I've re-implemented this in Fusion 360. There's a lot of cleanup I'd like to do. If we go and look at the sketches, you can see none of them are named, so it's kind of hard to go back in the history. Likewise, none of these are named, but I didn't want to take the time during this video to show you all of that. What I do want to show you is setting it up so that I can easily change the size of this. So the driving dimension here is this, because that's how large the opening has to be in the fascia. And I want to experiment or possibly create versions that have different diameters there. So the way we do that is, let me find it. There's a way we can set up parameters, change parameters. So I'm going to define a couple of parameters. The first parameter I'm going to define will be called, well, actually I think I only need one parameter. So the parameter is going to be hole diameter. And right now the value is, I said, 2.0 2¼ inches, I think is what it is. Okay, so that means we can go back to here, which is the, let me rename that. So this is the basically hole diameter. It's not really the diameter, it's going to be slightly less than the diameter, but we can put that in here now. So if we edit the sketch again and change this, now I can say this is equal to the hole diameter minus, let me subtract 0.1 inches. That's probably too much. 0.05 inches. Okay, so now this whole thing is driven by that diameter. Well, not completely, as you'll see. But let's see what happens if we change it. So let's go to change parameters, and let's change this to 3.25 and see what happens. I'm pretty sure I know what's going to happen. It's not going to be happy. And you can see why, which is that the outer part here is not relative to the diameter. It's actually absolute. So we have to change that as well. So if we go to that part, that's probably, yes, that's this sketch here. So I'll call this sketch the mounting plate. Let's go ahead and edit that sketch. And we'll change how it's defined. So instead of having this be an absolute dimension here, what we're going to do is dimension this distance here. Now, I can just click there, and now it's 1/8 of an inch. So, now if I go back and change the parameter to 3.25 inches, not quite. And that's because the square is not a square. But we can fix that. So going back to the mounting plate, what we can do is we can take this one here, and make them equal. So now it's perfect. That's exactly what we want. Everything is perfect. So I can go back and modify the parameter, put it back to 2.25, and there's my part. So that's pretty darn cool. Now the next step after this will be for me to start designing the mold. I'm also going to make a few other changes probably, but the important thing about this is to think about, if you're going to make a mold, to try to put the draft angle into the different areas as you design it rather than after the fact. I find that it takes a little bit more time to do that up front, but it certainly saves a whole lot of time later if you want to start making revisions.